We're demonstrating the GEIS Pathfinder tool. We're going to look at routing some fibre between the building at the bottom of the display and the complex to its north. So we'll set the building as the start point of our trace. And we'll use one of the complex's access points as the other end of the trace. At this time, we could, if we wanted, restrict the trace by specifying items that must or must not be included in the final path. We can specify how many fibres we're looking for and of what type. We can specify a trace factor, and this is simply how much longer than the straight line or crow flies distance that the trace is allowed to be. We hit the trace button and the tool finds 5 paths through the network that satisfy our criteria. We can drive to and highlight those paths. We'll pick on the shortest path and work with that. The tool is displaying the Path tab, which is a list of all the fibres available in every link in the trace. You'd normally be using dual monitors for this, but we can drive to the various structures and routes encountered along the way, and also synchronise the Path tab from items selected in the map. Going down the screen, we've got every fibre in every sheath in that particular link in the trace. Some of the fibres are shown with a coloured chevron, and this indicates that by convention that particular fibre is normally used for a particular purpose, in this instance, protection. There is some XML which the administrator uses to configure this. At each structure we've got information displaying how the fibres are actually connected. A dogleg indicates that a fibre is connected to something outside the path we're interested in. Unbroken fibres, or fibres connected straight through, are shown perhaps unsurprisingly as a straight line. We're trying to route 2 fibres, so in its simplest form this becomes an exercise in finding the gaps and splicing fibres together to make a continuous path. That is a straightforward matter of selecting the fibres we want and clicking the connect button. In this case I've selected fibres 1 and 2 on both sides of the gap, but it could equally well have been fibres 3 and 5 on the left to fibres 10 and 13 on the right. It's completely arbitrary. We've made our proposed connection. The red X's confirm that we're going to have to break some fibre to do that. From here it's a matter of identifying the remaining gaps and selecting appropriate fibres to join to complete the path. At this stage our path is now complete right through to the final structure, so we can generate a list of patching changes, and we can save these to disk so they could be given to somebody to actually make the changes out in the field. And we can then get the tool to also make those changes within PNI itself. Once the tool has rebuilt the Path tab, we can go back and inspect the results of our patching changes. Here we can see that the fibres we wanted have actually been spliced together, and we've now got an end-to-end path.